From falling leaves to speeding cars to orbiting planets, everything follows the same rule of motion. When we first think about motion, we consider object speed, time, distance, and so on. Yet in the physical world, direction is also important, as it tells us to where an object goes. This leads us to the important idea of vectors and scalars. Scalars are quantities that just has magnitude, or numeric values, and does not have direction. An example of a scalar will be time because it is defined solely by its magnitude and lacks spatial direction. We cannot say something like time is moving 3 seconds to the north. On the other hand, vectors are quantities that has both magnitude and direction. The direction tells us where something headed. An example of a vector quantity would be force, which is what we will be learning in Unit 2. We can apply the force upward, downward, etc. From our previous understanding of motion, distance is how far an object traveled. It usually has a unit of meters, and since it doesn't have any direction, it's a scalar quantity. An example for distance could be an odometer of a car, which records how far a car has traveled without indicating which direction it goes. A related term with distance is called displacement. Displacement is a change in position of an object. It also usually has a unit of meters. On a number line, we can have points on the left side of the zero and right side of the zero. Conventionally in physics, for a linear motion we view left as negative and right as positive. Given that position is a vector with direction, the changing position would also be a vector. A vivid example to understand displacement is imagining you're walking in a circle, starting at one point and walk back to where you start. We would find that despite we walked a lot, you have zero change in position, thus your displacement is zero. Mathematically, we calculate distance by adding the total distance traveled, and we calculate displacement by subtracting the initial position from the final position. Here's an example. Assume that we start at negative 10 on the number line. We travel to the right to positive 10 and go back to 0. If we are to calculate the distance, it will be 20 plus 10 equal to 30 meters, because we ignore the direction when we are calculating a scalar. However, when we are calculating the displacement, the final position, which is 0, minus the initial position, which is negative 10, gives us a displacement of 10 meters. A lot of students struggle to memorize whether it is finals minus initial or initial minus final. You can just think about that alphabetically. F, which stands for final, comes before I, which stands for initial. Another important factor of motion is the speed of an object. Speed by definition is the rate an object's distance traveled is changing, which is a bit confusing, but it's basically how fast an object moves. It has a unit of meters per second. You can think of speed on a speedometer, which does not tell you the direction, but the magnitude of the speed you're going. It indicates that speed is a scalar. Mathematically, we calculate average speed by dividing the distance traveled over time. For example, if an object traveled 10 meters in 2 seconds, then the speed of the object will be 5 meters per second. Just like distance, speed also have a vector version of itself called velocity. It's essentially the rate an object's position is changing, or how much the position changed by each second given the total displacement. The unit of velocity is also meters per second. Since displacement is a vector, the velocity is also a vector. It could tell us to which direction an object moves. We calculate the average velocity by dividing the displacement over time. For example, if an object moved 5 meters forward and 3 meters backward in 2 seconds, the changing position is 2 meters, so as a result, the average velocity will be 1 meters per second. Our last term today is acceleration. It is the rate velocity is changing, or you can think of it as how much velocity increased by every second. If a car has an acceleration of 1 meter per second squared, and the initial velocity is 0, at 1 second the car would have a velocity of 1 meters per second, and at 2 seconds the car would have a velocity of 2 meters per second. In this class, we will have constant acceleration, meaning we will not deal with acceleration that's changing, and the changing velocity will also be constant. The average velocity is calculated by dividing the change in velocity over time. That's why it has a unit of meters per second, which is just meter per second squared. As an example, if in 5 seconds a car speeds from rest to 60 meters per second, then the change in velocity would be final velocity, which is 60, minus initial velocity, which is 0 because it starts from rest, 60 meters per second. Over 5 seconds, the acceleration will be 12 meters per second squared. Alright, hopefully you get some basic knowledge about kinematic terms. Here are some practice questions. Take your time. I'll post the answer key in the comment section. If you have any questions, feel free to email me, and I'll see you next time.